This is our fall 2014 calculus ACP, and this is problem 3, which is an absolute value problem. And what we have is the absolute value with the limits from -3 to 3 of the quantity, absolute value of quantity x plus 2 dx. And what we have to look at is that when you look at an absolute value function, taking the integral of an absolute value function, you have some function like this that I'm drawing in blue. And if we're talking about the absolute value from this point value here a to b, the quantity when we integrate is going to be this area above the x-axis, and as far as this area below the x-axis, in purple, shaded in purple, this area is going to be positive also. So when we add the two areas together, it's going to be like this purple portion here is above the x-axis, and we add these two places together, areas together. So let's take a look at this function here. We have the function y, or f of x, equals x plus 2, and we're going to make a little sketch of what that function looks like. The key thing we need to find out here is where this function crosses the x-axis, because that's going to have an impact on how we evaluate. So if we set this x plus 2 equal to 0, and we solve for x, we get x equals -2. So if we go over here on our little hastily drawn sketch, the graph, the function crosses the x-axis here at x equals -2, and this is a slope of 1, so we're going up like this, and we're going all the way to, in our limits, x equals 3. So there's x equals 3. There's x equals -2, and then -3 is also crucial because that's our left limit. What we have is the area of this triangle. I'm going to put in red, shade in red. Okay, so that's this triangle, and its dimensions are going to be 5 in the base by, we're talking about a isosceles right triangle, that'll be 5 there also. And then this little corner here from -3 to -2 is below the x-axis. So if we find the area of this triangle above the x-axis and the absolute value or opposite of this area below the x-axis and add these two areas together, we're going to get our answer. Well, our answer for the big triangle above the x-axis is going to be our base times height, 5 by 5 divided by 2, which is going to be 25 divided by 2, and decimalized we'll have 12.5. So that's going to be our area of the big triangle. And of the little triangle we have a 1 by 1 divided by 2, which is going to be 1/2. So you're going to have 12.5 plus 1/2, which is going to be 13. And we can also work this problem out if we make the integral. We can put these two here. We're going to have the absolute value of -3 to -2 of x plus 2 dx. So that's going to be the absolute value of that plus -2 to 3. So analytically, we could work this out as well. And to do that, we would have absolute value of, we would have x squared over 2, right, taking the integral, plus 2 from -2, -3 to -2, the absolute value of that. So I have absolute value brackets around all this. So you end up getting -1/2, and of course the absolute value, plus you'll have -2 to 3 of, oops, excuse me, I need to do the solution here. You're going to get plus, same as before, x squared over 2 plus 2x, but in this case from -2 to 3, and evaluate this, you're going to get 12.5 here, you're going to get 1/2 here, you end up with the same thing. So I'm going to put a link to the previous, we rehearsed this before the test, I'm going to put a link to that previous video too. I wouldn't be surprised if you had a quiz related to this quite soon. Good luck, and thank you for viewing.